Ciao friends and welcome to a new video from SQL In this video, I want to elaborate on the difference between two DAX functions, which are summarize and GROUPBY. Both functions perform very similar tasks. You provide a table and they group that table by one of the columns of the expanded table. Both functions have the option of creating new columns which are added to the result set. Still, they are very different. Sometimes it is better to use summarize, sometimes it is better to use group by, sometimes you need to mix them in the same formula in order to obtain best performance. To make the long story very short, you need to use summarize whenever you want to group by a column that belongs to the model. And you need to use group by whenever you want to group by a column that you create through other DAX function, a local column created by using add columns or select columns. If you use the opposite system, then you will obtain really poor performance and possibly also unexpected values. But I want to explain you the details. So we are going to do a deep dive on how summarize works, how group by works, in order to understand the strength and the weaknesses of both functions. Let's start writing some DAX code together. Let's start by looking at summarize. Now, summarize groups by, so we can simply write evaluate, summarize, and then we summarize sales, grouping by product brand. This simple summarize just returns the different product brands. If I click on the results, you see we have Contoso, whiteboard importance, and so on. Summarize also has the option of creating new columns. So we can create the sales amount by just invoking the sales amount measure. And if I run this code, I have both the brand and the sales amount. Now, please do not do this. Don't. No. It's bad. Never, ever use summarize this way. The reason is summarize has the option of creating new columns, but in doing that, it uses a technique that is known as clustering. Clustering works absolutely fine in simple scenarios, but it creates really weird results as soon as the calculation is non-trivial. Let's go a bit deeper. Let's investigate on the server timings of this query. I probably need to enable it again and run the query again. This query is grouping by brand and computing the sales amount, and that generates two storage engine queries. The first one selects the brand, the sum of expression, where expression is quantity times net price, and the entire query is being executed inside the Vertipack engine. Then we have a second storage engine query that only retrieves the product brand, because that's the way summarize works. It queries for the axis of the result and for the different results, and then joins the two partial results together. The thing is, both queries only return 14 tables, so the level of materialization is really small, and performance is absolutely fine. However, things are very different if the code you write is non-trivial. Let's do something a bit more intricate, not a lot, just a bit more intricate. I create another calculation, let's call it sales all brands, that uses calculate, it computes the sales amount, and then I remove the filter from the product brand. Now, what's happening here is that I'm iterating the brands, so summarize generates a filter context that contains the brand, then it invokes calculate. Calculate removes the filter from the product brand column. Therefore, I would expect this sales amount to show the value, the grand total everywhere, the same value everywhere. If I execute this code and I look at the result, you see that that is not the case. That computes the sales amount, and sales all brands contains the same value as sales amount, as if my remove filters wasn't doing anything, which is actually the case. Because I'm using summarize and summarize uses clustering, even though I'm grouping only by brand, summarize actually places a filter on all the columns of the expanded table, generating a very complex filter that is not only slow, but also very hard to remove and very hard to interact with. Besides, performance-wise, we also have an issue. If we look at the server timings of this second query, you see that now that is very different. We have 3 queries. One is returning only 14 rows. The other 2 are returning 13,000 rows, 14,000 around, which is the size of our sales table. Indeed, the first scan is just grouping by product brand. The second scan is quite strange because it's retrieving all the columns of the sales table. The order number, the line number, the order date, all the columns are here. And the third query is quite similar. It retrieves again all the values of all the sales table. So both queries are retrieving basically the entire sales table. Now, with 14,000 rows, that is not a problem. The query is still super fast. But if your sales table contains hundreds of millions of rows, then suddenly this query will become extremely slow because it's materializing a lot, because that is needed in order for clustering to work. I'm not going to explain clustering here because that would be too long. But if you are interested in clustering, I have an article, All the Secrets of Summarize, here. Let me show you the link. It's here. Just search for All the Secrets of Summarize SQL BI. The article by itself is quite long and rather technical, so it takes some time to understand and digest everything. But at the end, the conclusion of the article, which is at the very beginning of the article itself, is do not use Summarize to compute new columns. Use Summarize for what it is best suitable for, that is, grouping. Grouping is the task of Summarize. Create a new column, that is not the task of Summarize. We have add columns for that. Whenever you have Summarize and you're using to create columns, then get rid of the create column and replace it with add columns. Let me show you this. Let's go back to our code. We have the results. You see sales or brands is wrong, but we can easily solve the problem if we add columns around Summarize. We use Summarize only to perform the grouping by. So Summarize is limited in its scope, only 3 lines of DAX code, and then the columns are generated by using add columns. If I run this code, now you see sales all brands computes the correct value. And if we take a look at the server timings, we have now an optimal scenario where we still have 3 queries, but look at the level of materialization, we have only 14 rows instead of 14,000. Why is Summarize using clustering? Well, because Summarize has the option of grouping not only by model columns, it can also group by columns which are created on the fly, local columns. For example, I might want to group my sales based on the quantity that I sold. If any single transaction sold more than 3 items in the same line, we consider it a large transaction. If there are less than 3 items, then it's a small transaction. And I want to group sales by large and small. Now, this column does not belong to my sales table, but I can create it on the fly in my DAX query and then group by it. Summarize has the option of doing that. Let's see that with the example. We can basically get rid of everything because we want to summarize. No, we want to do first add columns. We add the new column to sales. We call the column transaction size. And then the code just says if sales quantity is greater or equal or strictly greater than 3, then it is large. Otherwise, it is small. If closes here, and this closes add columns. Now, that generates a table with 14,000 rows and an additional column containing large or small, depending on the quantity being sold on that line. I'm not interested in retrieving 14,000 rows. I want to group them by the column. So I use Summarize around it. And then I create a new column that I call sales amount. No, I summarize first by the transaction size column. Okay. And then I compute the sales amount by computing the sales amount. So you see that this time I'm using summarize and I'm using it to group by the transaction size column. Transaction size does not belong to the model. It's a column that has been added on the fly. If I execute this code and I look at the result, you see that I have the transaction size and the sales amount of small and large. It works nicely, there is nothing wrong, but this query is still very slow because it is still using clustering. Therefore, it's performing a large materialization. Now, I don't want to elaborate on this right now, so let me just copy this code in a new panel because we are going to use it later. So we have seen summarize. Summarize lets you group by a model column or a local column, but it does it by using clustering. We do not want clustering, so in order to avoid clustering, we use add columns and then summarize. But when it comes to group by model column, summarize actually shines. When it comes to group by local column, summarize needs to use clustering, and it uses a technique that we want to avoid. This is what makes summarize the perfect function to group by model columns and not by local columns. For local columns, we have group by. Group by has the opposite behavior. Group by works absolutely well when you want to group by local columns, and it presents performance issues if you want to group by model columns. Let me show you again this with an example. We can get rid of this and let's pretend that we still want to group by brand and compute the sales amount, but this time we use group by. So we group by, we group sales, we group it by product brand, and that is the same that happened with summarize. And then we want the sales amount. And here is the problem. I cannot write sales amount. If I just write sales amount this way, and I execute the code, I obtain an error that says the function group by scalar expression have to be aggregation function over current group. What is the meaning of this? Well, group by is not like summarize. Summarize tries to push the calculation down to the storage engine, to the Vertipack storage engine, and takes advantage of it. Group by does not even try to perform the calculation in the storage engine. Group by will materialize the table that you want to group and then perform the grouping and the calculation inside the formula engine. That is why you have a limitation. The calculation that you perform needs to happen only with the columns that you are materializing. Therefore, in order to compute values with group by, you need to iterate over a special function that is named current group. Current group contains the rows of the table that is being grouped by with the value that is currently being iterated. So the same calculation cannot be expressed by using sales amount. That needs to be sum x over the special function current group. And now, while we are iterating over current group, we can use sales quantity times sales net price. If I write the code this way, now it works. It produces the correct results, the sales amount sliced by brand, but the code is different. And the most important thing is that I could not use sales amount here. I have to rewrite the code of sales amount by making the multiplication of quantity times net price. For a simple calculation like the sales amount, that is not a big deal. But if that was a much more complex function, then of course you would have to repeat a lot of code. Not only we do have a problem because of this, we also have a problem from the performance point of view. Because if we look at the server timings, you see that again, group by is retrieving 14,000 rows. Here we have. Therefore, the entire sales table is being retrieved. if we look at the code, it is not actually retrieving the entire sales table. It's only retrieving the columns which are needed. Because I'm performing the multiplication of quantity by the net price, it retrieves the product brand that is useful for the grouping by, the quantity, the net price, and then we have this special column row number that is needed in order to ensure that all the rows are being retrieved. Otherwise, Vertipack would perform an automatic grouping by, and group by does not want that because it's group by task instead of grouping by. So group by, when used with model columns or with any table that you need to group by, always materializes the entire table. That is a strong limitation. It makes it a very slow function if you are using it to group a large table. At the same time, group by has a very strong advantage. Group by is able to group any table by any column that belongs to the table without relying on the context transition or any other complex tax technique. So it achieves a goal that no other function is capable of. Let me show you again this with an example. I just need to find the code, so I write the same that we have in the article. Let's pretend that we have a table that is entirely local. So I define a variable, table to group, and table to group contains just a bunch of rows. Let's say contains A1. Then we add another row A2, and then a third row B3, and a fourth row B4. Okay, let me show you first the content of this table. Return table to group. I just ran it to look at the result, and this is the table that I'm creating. The important thing is that this table is entirely local. It's not a table in the model, it's just a local table, so it does not have any lineage. Now, if I want to summarize this table, I cannot use summarize, because I can use summarize to group by, but I cannot use summarize to compute the sum of this column. Let's give this column a name. So we use select columns, and the first column we call it group. That is value 1, and the second column we call it value. That is value 2. Let me again return the result just to see that it contains the right value. So we have group and value. Now, if I want to summarize it by group and compute the sum of values, I can't, because if I try to use summarize, I can summarize a table to group and summarize it by group. Let me format the code. If I run it, I obtain A and B. But when it comes to compute the new column, let's call it result, I cannot write sum of table to group value. Table to group value. That is just not valid syntax. If I try to run it and I look at the log, I have an error, because this column is not a column in the model. So I can use summarize to do the grouping by, but I cannot use summarize to perform calculations, because the table has no lineage. On the other hand, I can use group by. I can use group by, group it by group, and then compute a new column result that does not need to access a model column. It's just a sum x over the current group of the value column. Inside this iteration, I have the option of performing my calculation. And if I run it, I have my two rows, and in the result I have A3, B7. So the numbers are computed correctly. Therefore, let's draw some conclusions about group by. Group by might be very, very slow if you use it to group by a model column. So you have a large table, you group it by a model column. Group by will need to materialize the entire table, therefore performance will be really poor. On the other hand, group by works absolutely nice when you group by a column that you add to the model. a local column that you add through DAX functions. Nonetheless, the table you are grouping by, that needs to be a small table, because the larger the table, the larger the internal data structures that group by needs to create. That is why at the beginning of the video we started by saying use summarize to group by model columns, use group by to group by local columns, and use them wisely. Try to use the smallest table possible. Again, I want to show you this with an example. So I'm going to take the query that I saved at the beginning of the video, and then we inspect the storage engine queries of the query. We try to reason on top of performance, and then we make it faster. In order to make it faster, we will need to combine in the same piece of code both group by and summarize, using both functions in the best way. So summarize to group by the model columns and group by to perform the further calculation. So let's start by taking the code that we wrote at the beginning. Let me copy it back in the main window. This query is computing the transaction size and it's computing large, small, and then it's using summarize. Let's take a look at the complexity of this query using summarize and add columns. If I run the code, I obtain my result. But when I look at the server timings, you see that the query is quite complex. First, we have a storage engine query that retrieves basically the entire sales table. So that is going to be a very large storage engine query. And then we have a second storage engine query that is even worse, because it's not only retrieving all the columns in sales, it also has this gigantic filtering basically all the rows in sales that needs to be placed. Therefore, we have two issues. The size of the result set, it's very large, and the size of the filter, that is going to be extremely large. So this query works absolutely fine on a very small model, but on a medium size or on a large model, that query is going to kill everything. So what if I use group by? Because at the end we said, well, we are grouping by a column that is being created on the fly. So instead of this, I can use group by. I leave the code as it is. I group by transaction size, and I know I cannot write sales amount, but I can write sum x over the current group of sales quantity times sales net price. Same thing that we did before. Now, using group by, I would expect performance to be a bit better, but we need to check it. So let's run it. We have still our result. That is not interesting. The interesting part is performance. Now we have only one query, which is better. Still, the query is retrieving 14,000 rows, so it's still going to be a very large query. However, the big advantage is that now we are no longer retrieving the entire sales table, we are only retrieving the columns that are needed, which are namely quantity, net price, and the row number, in order to guarantee that we are retrieving the values the right way. And then we are adding the column, we are not grouping by anything else, so this is just the list of values which is retrieved. Then the formula engine will compute this column and finally perform the grouping by. Still, this query has quite a big issue because it needs to materialize a table which has the same cardinality as the fact table. 14,000 is not an issue. A billion would be a nightmare, but already a few millions would start to show that speed is not perfect. So why not use both functions at the same time? What if instead of grouping by the transaction size immediately, we notice that this code only depends on the sales quantity? So we can group all the sales that share the same value for the quantity in just one bucket. Then we compute the transaction size for that bucket, and finally we compute the value. So we use summarize to group by sales quantity, then we compute the transaction size, and finally we use group by to perform the last operation. So let me show you the details. What we can do is, again, let me look at the code. So I read the same that we have in the article. we add column, instead of using add columns, we still use add columns, but we summarize sales, and we summarize it by sales quantity. Now, the result of this table is a table that contains one row per value of quantity. We have a small number of values in the quantity table. In the quantity column, I don't remember, but around 10, 20 different values. So the resulting table will be very small. And then, at the same time, we also compute, using add columns, the sales, which is the sales amount. Let me prefix this with a net symbol. That closes add columns, and let me get rid of everything from here. Let's take a look at this first partial result. If I run it, I obtain a table that contains the quantity, the value of sales, and then the transaction size. We only have 9, 10 different values. So the resulting table is very small, and it contains the quantity and the sales. We do have a table with a small number of values. We can group it by using group by. So we use group by around everything. And now we use group by for what it does best. We group by transaction size. And finally, we use a sum x over the current group on the column sales. And if I did everything correctly, I can now run this code, which does not, because I have a problem. I forgot a column, the column name, result. Okay. If I look at the result, now I have transaction size, result. And if I look at the server timings, you see that now we do have optimal performance. We have a first query that groups by quantity and retrieves only 13 rows. And then we have a second query that only retrieves the value of the sales quantity. So the calculation of grouping by quantity and the calculation of the sales amount, that is the scan of the sales table, happen inside the storage engine. And the formula engine only performs the grouping of a table containing 10 rows. But in order to achieve this result, we had to combine in the same piece of code both summarize and group by. As you have seen, despite looking quite close, group by and summarize actually have a completely different internal behavior. The more you know about the internals, the better your DAX code will be, because you will learn how to use the function for what it does best. Summarize is useful to group by model columns, and that's it. If you want new columns, you use add columns. Group by is useful to group by local columns created on the fly on small tables. You never use group by to group a model table by a model column, because that would trigger the materialization of the entire table. Enjoy DAX!